Hi guys, welcome to another lecture in RT Dowlett lecture series, and this has to do with CSEC physics, and I am going to talk a little bit about electricity. Now this lecture is very good for students who just want to grasp an understanding of electricity. As part of your NCSE syllabus, you do some fundamental calculations regarding series and parallel circuits as well as Ohm's law, and of course we just amplify it at the CAPE level. So we're going to start off with an introduction to electricity, and when I talk about electricity, we are going to talk about the movement of a charge. So we are talking about either the movement of positive charges or the movement of negative charges, or both, right? So it depends on your medium. So when we talk about these positive and negative charges, they originate in the atom itself. So here in the atom, you would have a nucleus of positive charge, and that is surrounded by negative electrons. Okay, now because of their proximity, it is easiest for negative charges to move. But there are situations, there are substances where positive charges are easy to move, and when they flow, they result in a current. Now when we talk about a current, right, we are talking about the movement of a charge, and the definition from a physics perspective is that it is the rate of flow of charge, and that of course is talking about both positive and negative charges. Okay, so here we're going to focus in the first video a little bit on current. So we're going to talk about current being I, and that's equal to the charge Q over the time period. Now current is measured in the amp, Q is measured in the coulomb, and time is measured in the second. So 1 ampere is 1 coulomb per second. Now you can consider a formula pyramid where you have charge over time, and you can use it to solve for current. So let's say that I wanted to get a charge of, let's say, 10 coulombs, and it is flowing for 1 second. Then easily I could say the current flowing is Q over T, which is 10 over 1, which is 10 amps. Now this is easy because the quantities are already in the SI unit. What happens if I wanted to get, for example, the same current, but if my charge of 10 coulomb now flows for 1 minute? Then that's different, because now I have to work out the conversion from time in minutes to time in seconds. So I is Q over T, and that's equal to 10 over 60, which works out to be 0.17 amperes. Okay. All right. So if I wanted to get time, right, that is, if I go up to my pyramid here, right, I can see that time, I cover T, so it's Q over I, right? So here, if I had a charge, for example, of 100 coulombs, and I divide it by a current of 2 amps, then 2 into this is 50 seconds. In the same way, if I wanted to get Q, that is equal to IT. So if I have a current of 3 amps flowing for, let's say, 2 hours, I have to work out hours into seconds. So therefore, it becomes 3 by 2. How many hours, how many minutes make up an hour? 60. And how many minutes make up, 60 seconds make up a minute, sorry, and 60 minutes make up an hour. So that's multiplied by 3600. So I multiply this now by 6, and I get 21,600 coulombs. Now when we talk about a current, and we talk about it being the movement of positive charges, right, that is what we call a conventional current. Conversely, if you have the movement of negative charges, that is an electron. So I can represent, I'm not too sure if you all are familiar with these symbols used, but I can show a battery by 1 long stroke, 1 short stroke. So I have positive, I have negative. So here, what happens, I have my wire, and we use this symbol for a bulb. And here, right? This is negative terminal, positive terminal. In my next video, I will go into more detail about voltage, right? So here we are considering the movement of positive charges, right? Because the positive charges would be repelled by the positive terminal, they become attracted to the negative terminal, because you will recall that opposite charges attract, like charges repel. So in that case, you have the battery promoting the charges by giving them energy, and as a result, it results in the circulation within the circuit itself. Now this is an example of conventional current. Now I could look on the other hand at here, if I change the polarity of my battery, right, and I consider now the movement of negative charges. So the negative charges will be repelled by the negative terminal and they become attracted to the positive. So this flow is what I call electron flow. Now in dealing with current, there is a device that is used to measure current, and that is called the ammeter. So here you have the ammeter, and the symbol is a circle with an A. Now two things you have to know about an ammeter. It is always connected in series, right? And in one of my subsequent videos, I'll explain what a series path is. And the second thing is that it has a very low resistance. Now, when you talk about a current, one of the things that will come up is a specific law, and it is something that we would look at the Cape level, which is called Kirchhoff's law. Right. And Kirchhoff's law is basically where we have either a law of voltage or current. In this video, because we are dealing solely with current, we're going to talk about the current law. Right? So what this law says is that the net current at a junction is zero. What do I mean? Now in physics, we have when wires cross, that doesn't mean that there is an electrical connection. So for me to show that these wires are electrically connected, right, there is a junction at this point here. A junction is basically where wires electrically connect. So there is an electrical connection amongst the wires, and when that happens, you have all of the current flowing towards the junction is equal to all of the current flowing away from the junction. So therefore, I can now create an equation. I could say I1 plus I2 is I3 plus I4. So everything going towards the junction is equal to everything going away from the junction. Okay? Now, when I consider a current, I can consider a current flowing in one direction. So let's consider a battery. A battery has current flowing either conventionally or using electron flow. But at the end of the day, the current is moving in one direction. So here, if I have a current time graph, I could show the current being a flat line, and this is what I call a DC value because it is a direct current. The current is flowing in one particular direction. Now, many times your direct current tends to be a constant value. Now here, right, you could also show it having, you could have it being slightly rippled, which means it's approximately the same value. Now, conversely, we can have an alternating current, and that is symbolized by a circle with, what we call a sine wave, a small sine wave. Now, what these sources do, we call them an alternating source, and what they produce is an alternating current. And that is symbolized by the acronym AC. Now here, the current has two directions, so it is bidirectional. So here you will find that this is positive, this is negative. Conversely, right, based on how this source originates, I can have here the polarity of my source changes. So when the polarity of my source changes, it allows my current to flow in two directions. So on one hand, it could flow positive to negative, right? And where the positive terminal is on the left-hand side, and when the polarity of the source switches, then goes to the right, then my current goes same positive to negative, but in the opposite direction, right? So to symbolize that, again, I sketch a current time graph, and I notice I have this sine wave signal. So this is basically everything you, in a nutshell, need to know about current, and the theory will take you all the way from NCSE to CSEC to KEEP. All right. The last thing I wanted to touch on before I end is the conversion from direct to alternating. So if I wanted to go from an AC all the way to a DC, I use a process which is called rectification. And that is using a component called a diode.